Section 3.4, we're going to discuss the slope of a line. So slope's a concept that you're actually probably familiar with. If you've ever driven around, I think it might be a little too dark. If you want to, Kendra, can you hit the lights on the left of you? Yeah. I don't know. Can you see that? What's it say underneath that sign there? Right here. 17% grade. That's pretty steep. You would not be really happy trying to ride a bike up that hill. Not at all. This is in San Francisco. This one is in Pennsylvania, southeast of Pittsburgh. Runaway truck ramp. Has anyone ever seen one of these things? They have them around in Colorado and other places where it's really mountainous, where it's pretty hilly. And it's a gravel road that you drive a truck up in case your brakes fail. It gives you a place to go, to slow down and stop without crashing into all kinds of things. Oops. Here's what I think of when I think of slope. Yeah, these are slopes. This is where I like to ski out in Aspen. This is Aspen Highlands. And a more up close and personal look would be right here and here. So nice stuff, steep and deep. Now what I want you to think about when looking at this slide is which slope is steeper? This one here or this one here? First one or the second? Which one's steeper? The second one's steeper? All right, the first one's steeper. All right, now, extra credit opportunity. Which one does your instructor ski? The first one or the second one? Oh, man, you wound me. First one. It's called Steeplechase, locally known as Deathman. All right, so what you're doing, though, when you're trying to figure out the slope is you're mentally comparing two things. You're mentally comparing the rise, which is your vertical change, to the run, which is your horizontal change. So it's the ratio of those two that form the idea of the slope. So we need a formula for the slope. The slope of a line between 2 points. What would that be? Oh, that was beautiful. Rise over the run, and the formula turns out to be y2 minus y1 over x2 minus x1. That's actually on your handout. So let's look at that there. And then practice with it. So y2 minus y1 over x2 minus x1. You want to bring up the lights there again? Thank you. Okay. So let's find the slope of a line between these 2 points, say 1 and 3 and 6 and 4. So those 2 points, that would be this one and this one. Let's play connect the dots real quick. I want to find the slope of that line. A lot of times I find it helpful to label it x1, y1, x2, and y2. Now let's fill in our formula. That formula right up here, y2 minus y1 over x2 minus x1. Someone want to help me fill out that formula? What's the numerator going to look like? 4 minus 3 over 6 minus 1. So a slope of 1/5. When you go over 5, you go up 1. Okay. Not so bad. Let's try the next one. Slope of a line between 1 and 3 and 6 and 1. So this time, we're looking at the slope of a line between these two. Let's fill in our formula for the slope again. Someone else here. Don, what's that going to look like? x1, y1, x2, and y2. Can you fill in the slope formula for me here? Good. So I end up with negative 2 over 5. So the calculation's not that remarkable. But what I want you to notice, though, is that unlike the first one, the slope here is negative. So I've got a negative slope, whereas in the first one I had a positive slope. One of the things I'd like you to be able to do from this section is recognize, what the slope is. Is it positive? Is it increasing as you move from left to right? Or is it negative? It's decreasing when you move from left to right. Our next example is going to ask us to try and find the slope of a line between these 2 points, 1 and 1 and 6 and 1. Any predictions, just visually, what's the slope of the line look like? 0, right? Doesn't look like there's any slope. 0 slope. So let's see if that matches our expectations. x1, y1, x2, y2. Andrew, can you fill in that formula for me here? Good. 1 minus 1 over 6 minus 1. Is 0 divided by 5 undefined? What is it? 0. So it matches our expectations. Would this be fun for your instructor to ski down? No. That'd be pretty boring. That's cross-country skiing. It's not downhill. All right. Last one here. Between 6 and 4 and 6 and 1. So we're looking at these two right here. So m is 1 minus 4 over 6 minus 6. Kasnaya, what do we get here? Negative 3 over 0. What's negative 3 over 0? Undefined. Undefined. So there's 4 different types of things that can happen when you're trying to calculate the slope of a line. You can have a positive slope, a negative slope, a 0 slope, or an undefined slope. Those are the 4 different types of things that can happen to you while you're trying to find the slope of a line. What I want you to do for the 4 graphs below is label them. What kind of a slope do you see in these lines? Positive, negative, 0, or undefined. So label all 4 of these. And then turn to a neighbor. Compare your answers. Try and decide, hey, did I get these things right? If not, argue about it and convince each other that you're right, that your neighbor is wrong. These? Yep. Did you guys compare notes? Kendra needs a friend. Compare notes. Nick, who are you friends with? Oh, not Victoria. All right, good man. Yeah, Ted needs a buddy. Who'd you buddy up with? All right, good job. Oh, and Micah? All right, you're networking then. Cool. It's a good thing.
You ever going to Vail? You been there?
Oh, yeah. Vail.
Cool?
Vail's huge.
I know.
The city of Huntington Woods could fit inside of Vail like 4 times over.
Yeah.
It's just amazingly big. All right. So let's take a look here. Jacqueline, how about the first one here, problem number 22? What kind of slope are we looking at? Negative. Good. Negative. Who else? Karanja. How about problem 28? What kind of slope is this one? Is that 0? Which one? That one's undefined. Vertical line's going to have an undefined slope. Your instructor would not like to ski down that. That'd be even a little difficult for me. All right. So undefined. How about problem 24? Positive. Good. Positive. And the last one, 0. Big 0. That's Pine Knob. All right. Okay. Let's do a couple more here. Let's move on to problem number 40. This is on the back side of your handout. Now, typically speaking, you're not going to have a graph available, but since we do, let's take a look at the graph and plot these 2 points. So 6 and -2, that's down here. -3 and +2, what quadrant is -3 and +2 going to be in? Yeah, so it's going to be up here in the second quadrant, -3 and +2. Why do you think I want you to graph this line here before we calculate its slope? Yeah, to see what to expect. What do we expect from this one, Victoria, in terms of a slope? Yeah, you expect a negative slope. If you got something different, well, there's a mistake somewhere, okay? And what I'm trying to get you to do is do some critical thinking. Just because you get an answer, don't necessarily assume that it's right. Try and look back at it. So x1, y1, x2, and y2. There's actually another reason I chose this. The first set of examples we did were pretty easy because we didn't have to deal with any negative numbers. But here, you got to be a little bit careful. So we've got 2 minus what? -2. You got to be careful with that double negative. Yeah, it becomes a plus. How about in the denominator? Good. -3 minus 6. All right, that's a really ugly -3. In the numerator, I get 4. What do I get in the denominator? -9. So typically you write that as -4/9, or you could also write it as -4/9. Actually, the negative more out in front here. -4/9. It's all the same. But it does match our expectations. It does have a negative slope. Problem 44. Same kind of thing. We've got points at -1 and -12. So that'd be down here. And then 6 and -12. So again, you've got a nice graph here that's telling you really what you should expect from the slope when you calculate it. See if you can't fill it in and make your calculations match your expectations. So that double negative here, that changes this to a plus. I end up with -12 plus 12, which is 0/7. Overall, what's the slope of this line? 0. Exactly what you expected. You don't have to work with just nice integer numbers. You can work with stuff like number 50. Now, I'm not graphing this one. We're just going to be kind of stuck here. The good news is that you can use calculators. There's nothing wrong with that. So, x1, y1, x2, y2. Mark, can you fill in these points here for me? What would that look like when I calculate the slope? Let me remind you of the formula right here. So 4.2 minus -7.2 over what? -8.8 minus 6.4. You seeing where those numbers are coming from? Okay. We got a double negative here, so it's 4.2 plus 7.2. Yeah, 11.4. Let's see. Add the numbers, keep the sign. So negative 8.8 plus negative 6.4 is going to be what? Negative 15.2? And like we did with the other one, the negative, typically you put it out in front, like this, or in the numerator. It's not that it's wrong in the denominator, it just looks ugly, that's all. One thing that you didn't ask about was, does it really make a difference, or does it make a difference what we label x1, y1 and what we label x2, y2? Does that make a difference? Yes. All right, let's find out. So with this example down here, let's start out with 2 comma 4 and negative 1 comma negative 1, and I'll label this one x1, y1 and x2, y2. Now the calculation's already done for you, right? You can double check it. Or did I get this one backwards? No. y2 minus y1 over x2 minus x1. It simplifies to negative 5 over negative 3. And negative divided by negative is positive. But what if I switch the order around? What if I said, okay, well, let's call negative 1, x1, y1, and 2 and 4, x2, y2. Did it make a difference in my calculation of the slope? I got 5/3 both times, didn't I? That's good news. It doesn't really matter what you call your x1, y1 and what you call your x2, y2. All right? It's still the same 2 points. It's still going to be a negative or positive slope regardless of which one you call x1, y1 and x2, y2. It's still going to be a negative or positive, whatever. So that's actually good news. You don't have to worry about which one you call which. In fact, sometimes it's more convenient to do calculations one way than the other. All right. There's a little tiny bit we'll finish up next time about parallel, perpendicular, etc. But parallel lines have the same slope. And if you look at this last one, x1, y1, x2, y2, the slope of this line, 5 minus 0 or 11 minus 8, is 5/3. If they have the same slope, what must be true about the lines? They must be parallel if they're the same slope. All right, let me give you some homework. For homework, let's see. Try 21 through 49. And let's see. Yeah. All right, that's it. Fine. That's it. What an easy touch, man. All right. Have a great weekend. See ya.